And today I want to look at the question, how much time? Well, when we consider the Earth, we are usually told there's lots and lots of time. About 4,500 million years of it. Well, that's what we're usually told, but there are a few observations which don't fit too well with that. For example, there are rocks in the Earth with radioactive materials in them. And those radioactive materials are breaking down. And when they break down, they release helium. And that helium is a light gas, it gets up into the atmosphere, and it stays in the atmosphere. We know how quickly helium is being added because we know how quickly it's breaking down. And we know how much there is in the atmosphere. There is enough to account for the known processes going on for about 10,000 years. It's called the problem of the missing helium, because if the Earth is any older than 10,000 years, all the helium that should be there is missing. Then we've got another problem, that is carbon-14. Carbon-14 is being produced from nitrogen-14 by neutrons caused by cosmic rays, and the rate at which this is going on is known. The amount of carbon-14 in the atmosphere is known. There is enough to account for this known process going on for about 10,000 years. Now, that explains why the radiocarbon dating method doesn't work. But this suggests that we're looking at a few thousand years, not a few thousand million. Then there's the Earth's magnetic field. Basically, it's a dipole, but it is pushed out of shape by the solar wind. That field is there because of electric currents circulating in the Earth's iron core. That current is collapsing, it's getting smaller. So the magnetic flux is collapsing. The measurements show it is decaying away. It is the fastest known geophysical phenomenon, the decay of the magnetic field. Its half-life is about 1,400 years, which means 1,400 years ago, it's twice as strong as it is now. 1,400 years before that, it was 4 times as strong as it is now. This field is fading away so quickly that in about 2,000 years it will no longer be able to make a magnetic compass point north. A consequence of this is, if you go back in time, the amount of energy in the system goes up very rapidly. And if you push this decay back very far, you find the heating effect of this current kills anything on Earth because it's too hot. A little bit before that, it boils the oceans away, and a few years beyond that, it melts the whole Earth. So it would appear that one can push the magnetic field collapse back to something like 10,000 years, and not much more. There's also the problem of minerals in the oceans. Minerals like nickel. The rainfall carries minerals into the rivers flow into the sea. One can measure the concentration of minerals in the rivers. So we know how much is flowing into the oceans. We can measure the concentrations in the oceans. And there is enough of things like nickel and uranium to account for this process going on for about 10,000 years. Now, all these estimates assume that in the beginning there was nothing there. So 10,000 years is an upper limit. If there was some there in the oceans beforehand, then you could account for it in less time. Well then, we might ask, since there is quite a bit of evidence that says just a few thousand years, where does the idea of thousands of millions of years come from? Well, most people are under the impression, because they have been given the impression, that it comes from radiometric dating, which most people have been assured is very accurate, and it's absolutely a certain, sound, solid method. All radiometric dating methods work on the same principle. You have some radioactive material like uranium, and in time it just spontaneously breaks down, gives off helium nuclei, and eventually goes through a whole series of decompositions, and it ends up as lead. Now, the uranium is called the parent, and the lead is called the daughter element. So what you do is you look at a piece of rock and see if it's got some uranium and lead in it, and you assume that all the lead there came from uranium, and you work out how long would it have taken for that much lead to be produced. It's a very limited range of rocks that you can attempt to date by radiometric dating. Now, people seem to think that fossils are dated radiometrically. It's not true. You cannot date any fossil radiometrically. The only kind of rock that you can do a dating on is volcanic rock. And you don't have fossils formed in rock that hot. Now, the reason is that you assume that when material is thrown out of a volcano, there's so much movement going on here that any parent next to daughter element that was there in the earth gets separated. So now you end up with a nice pure specimen of uranium or whatever it is you're working with, and as soon as that rock solidifies, nothing else is going to move in or out, and lots of other assumptions too. You can say we start off with some pure uranium and we'll see how much lead there is later. Well, you have to assume that no lead moves in or out, no uranium moves in or out. And as Henry Fole pointed out in Ages of Rocks and Planets, uranium and lead both migrate in geologic time, and detailed analyses have shown that useful ages cannot be obtained with them. Widely divergent ages can be measured on samples from the same spot. Now, this is why radiometric dating laboratories will not do a dating unless you tell them the age you think it is. Because you get a piece of rock, you take one sample and do a dating, and you find it says 10 million years. You take the next piece from the same sample, and oh, this says 0 years. You take the next one, 1 million years. The next one, 300 million years. So you line up all your results, and now the client said he thought it was 10 million years. Here we are. There we are. That's the date we give him. The people who do the radiometric dating know perfectly well it is valueless. Now, Robert Gentry is a world expert on one of the more interesting of the radiometric dating methods. It's called radio halo method, and his research led him to this conclusion. If isotope ratios are to be used as a basis of geologic dating, then presently accepted ages may be too high by a factor of 10,000. Thus, ages of the entire stratigraphic column may contain epochs less than 0.01% of the duration of those now accepted and found in the literature. So those ages that we are always told about, if they're of any value at all, they may be inflated by 10,000 times. But that's if they're of any use at all. The only way you can test a radiometric dating method is to date rocks of known age and see how good it agrees with it. Well, the only rocks of known age are pretty recent ones, volcanic rocks. Just over 100 years ago, there was a volcano on Hawaii, a volcano called Hualalai, which erupted. Lava came out, and about 30 years ago, a group of dating experts went to try out various dating methods on this rock of known age. Now, they used two very well-respected methods, potassium argon and uranium lead. Now, potassium argon said this lava was poured out between 60 million and 160 million years ago. Uranium lead said 3,000 million. So you can see, if isotope ratios are to be used at all, then they're probably wrong by a huge factor. But there's such a huge range between 60 million and 3,000 million that, well, how are you going to choose a factor that will cover a range like that? They are totally, utterly useless. Now, of the radiometric dating methods, the only one that has any kind of reliability, the one that's by far the best, is radiocarbon. But radiocarbon cannot date fossils. It can only date material which was living and has recognizable remains, but not if they've been turned to fossils. Now, the radiocarbon dating method is the most reliable of the radiometric dating methods, and it is utterly and completely unreliable. It was developed by Professor Willard Libby, and he wrote a very interesting book. It's just called Radiocarbon Dating. I can recommend anybody to read that book. On page 7, it gives you all the information which shows you that the radiocarbon dating method cannot work. But besides that book, he introduced it in Science, one of the top journals of science, in 1961. It's interesting to see what he had to say. The research and the development of the radiocarbon dating technique consisted of 2 stages: dating samples from the historic and prehistoric epochs, respectively. Why does it need to do that? Well, it's so obvious that all the radiometric dating methods don't work. What he wanted to do was calibrate this with known ages. And then when you've calibrated the method so that it will agree with known ages, then you can look at ages that are not known with perhaps some chance that it might give you a reasonable estimate. So he first of all has to date samples from the historic time. Arnold, that's his co-worker, and I had our first shock when our advisors informed us that history extended back only for 5,000 years. Well, here we've got a very well-educated man, a professor working on dating methods, and now when he comes to the crunch, then they admit to him, well, actually, history only goes back 5,000 years. You read statements to the effect that such and such a society or archaeological site is 20,000 years old. We learned, rather, that these numbers, these ancient ages, are not known accurately. In fact, the earliest historical date that has been established with any degree of certainty is about the time of the first dynasty of Egypt, about 2000 BC. 4,000 years ago. And that is the oldest date which has any degree of certainty. Any older than 4,000 years, it is speculation. If it's all speculation, is there anything that geology has got to tell us? which can claim a great age. When I first started giving lectures, the one thing that the geologists always hammered on, varves. Now this is a piece of varved rock, and you can see it's got stripes in it. Now those are alternate layers of fine and coarse material. And the story we were told was each of those bands, each of those pairs, represents 1 year. Because in summer, when the floods come, when the glaciers melt, the current of water is strong enough to carry in all sorts of sediment, and the sand immediately settles out on the bottom of the lake. But the clay only settles down slowly after the rivers have stopped flowing in for the year. So the sand is what's washed in the wet season, and the clay settles out in the dry season. So each layer, coarse, fine, 1 year. Lots of years. In fact, there are places where you can see hundreds of thousands of them. So obviously, we've got hundreds and thousands, even millions of years. Well, I didn't have any answer to that at the time, but in the 1990s, a French scientist did some experiments. And he found that when he had a mixture of coarse and fine material and he deposited it through water, something very strange happened. The material falling onto the surface added energy and made the material underneath sort itself into varves. He could get hundreds of them in just a short time by pouring a mixture through water. He ground up varved rock, poured it through water, and found it took up bands exactly the same thickness that the original rock had. This is nothing to do with 1 layer per year. This is to do with mechanical sorting using the energy of the material falling on top of it. There are no millions of years here. It's all quickly deposited. So that story falls away. Well, geology isn't left with very much, which probably explains why the geology department at the university here won't debate their timescale with me. I gave a series of lectures at the university a few years ago, and the professor of biology and the professor of geology got together and went to the university authorities and had me banned from giving lectures on the campus. And somebody from the maths department said, "This is interesting. Are you not prepared to defend what you're saying? How about a debate?" They said, "No chance." Why won't they debate? Well, they know that all their stories disappear as soon as you look at them in the light of science. Well, if there's nothing in geology, what about other fields? We're told of millions of years when we deal with astronomy too. Well, astronomy, very interesting subject. And you find beautiful objects like this. Anybody recognize what we've got there? It's the Horsehead Nebula in Orion. And down here you can see this bright light here. That's the famous Great Nebula in Orion. If we reduce the exposure and have a look, we'll see how beautiful that nebula is. And right in the middle, there's an interesting area there. We need to zoom in and reduce the exposure a little there. And then we find a famous little cluster called the trapezium. Orion is flying apart. Almost all star clusters are flying apart. The trapezium is small enough to measure quite accurately. Measurements have been done of how quickly it's flying apart. It's going so quickly that 10,000 years ago they would all have been at one point. It's hard to see how they can be more than 10,000 years old. Well, everything's flying apart in astronomy. The clusters of galaxies, for example, they're flying apart so quickly that if the universe was really billions of years old, there shouldn't be any clusters left. They should have all disrupted millions and billions of years ago. And yet they're all still there. In fact, you don't find any galaxies that are not in clusters. They're flying apart, but they're still all together. Well, this is a bit of a problem, because if you want to believe in thousands of millions of years and still have galaxy clusters together, you have to invent something cunning. So what they've invented, they call dark matter. Have you heard of dark matter? Dark matter has mass, but you cannot see it in any way. You cannot detect it in any way. That dark matter is needed to hold everything together so that it can last for thousands of millions of years. And it's not just a little bit. In order to have this hang together for thousands of millions of years, 99% of all the material in the universe has to be this dark matter, which cannot be seen or detected in any way. Now, Einstein said, what can be measured is science, everything else is speculation. Can you measure something that cannot be seen or detected in any way? This sounds like speculation, not science. The observations say these thousands of millions of years cannot exist. They are pure speculation. Well, it's not just the galaxies, the stars which present problems for all these millions of years. When we look at the planets, we find problems there too. Now, this is Saturn. I'm sure you have seen pictures, even if you haven't looked at it through a telescope. And the stunning thing about Saturn is its rings. There are two rings separated by what's called Cassini's division, because Cassini was the astronomer who first noticed it. It is believed, it's been stated for a long time, that division is there because the nearest moons of Saturn are in what's called a harmonic orbit. And each time those moons go around, they sweep out a little bit of material out of Cassini's division. And the calculations show that if this is so, then within 100,000 years, this should have been swept as clean as a whistle. This photograph was taken by Voyager 1 as it went past. And when they decided to send Voyager 2, they said, what we'll do is we'll send Voyager 2 in between the rings in Cassini's division so it can take photographs of the rings on either side. So they sent Voyager 2, and when it got in position to go through Cassini's division, it sent back pictures and amazed everybody. Because Cassini's division has got much less material than elsewhere, but it's very, very far from empty. There's still quite a lot of material there. They realized if Voyager went through there, it would be smashed to pieces. So they had to change their plan. It's obvious that those moons have not been sweeping for 100,000 years. And the astronomers realized there is a big problem with their millions of years. In New Scientist, they pointed out, as planetary scientists have realized, if the rings really had been gathering space dust for billions of years, their ice ought to be dark and grimy by now. They're too clean to be that old. Well, everybody should have known that before they ever sent a Voyager up, because ever since these rings were first observed by Huygens, They have been measured to be collapsing. They are collapsing onto the planet's surface, and the calculations show in 2,000 years this whole ring will be gone. The rings of Saturn are a short-term phenomenon. They cannot last very long. They cannot have been there very long. Another short-term phenomenon, comets. Now this is Ikea Seiki. You can't actually see the comet. All this that you can see is material which has been evaporated off the comet and blown out into space by the solar wind. The comet itself is just a small body, too small to see. It's about 10 kilometers in diameter. And all this is material being evaporated off it by the sun, lost forever. And this is about 1 million kilometers wide and many millions of kilometers long. A comet like this, like Halley's Comet, when it's near the sun, it is losing about 10 tons of material every second. And it's only 10 kilometers in diameter. So it cannot continue to lose 10 tons every second and carry on for very long. And it has been calculated that the absolute maximum that a short period comet could exist is about 10,000 years. But we've still got comets, which means we're looking at a period of less than 10,000 years. Well, that doesn't go down too well with someone who wants to have millions, so they have proposed a wonderful phenomenon, a wonderful structure called the Oort cloud, which is an enormous cloud of comets, thousands of millions of billions of trillions of them surrounding the solar system, but so far away they cannot be seen or detected in any way. As Carl Sagan pointed out in Comet, a very well-known book, many scientific papers are written each year about the Oort cloud, its origin, its properties, its evolution, yet there is not a shred of observational evidence for its existence. Well, since then, they've decided to look for another source of comets, which they call the Kuiper Belt. One of the reasons they did that was because all the calculations showed that even if comets did come in from the Oort cloud, they would simply get catapulted around the sun and thrown out into space in just the same way that the Voyager probes get catapulted around the planets. Can't work. So they proposed the Kuiper Belt. That doesn't work either. The comets still point to just a few thousand years. But what about the stars? Now, I'm sure we're all familiar with the story of stellar evolution. You have a cloud of gas and dust, which somehow, nobody ever tells you how, comes together and gravity pulls it together, so it becomes a tight mass of material. The maths show that can't happen, but it happens in the popular story. And eventually, this becomes so dense, it gets so hot that nuclear reactions start on the inside. And those nuclear reactions turn it into a star. And as time goes on, those nuclear reactions build up new atoms in the star. The composition changes, the temperature changes. These things blow up to be huge red giants, and then they start to collapse again and get smaller, and they become blue and white. And some of them explode as supernovas, and those which don't gradually get smaller, and they become yellow, and then orange, and then red, and then brown, and then they fade away. Each step in this process takes millions of years. And the whole process takes thousands of millions of years. Question: has anybody anybody observed this going on for thousands of millions of years? No. But people have observed stars over a few thousand years. Sirius, for example, the brightest star in the sky, because it's the brightest star in the sky, the very earliest astronomers observed it and made notes of it. And all the records of the early astronomers up to 150 AD showed Sirius to be what we would call today a red giant. But by 1000 AD, all the reports on Sirius show it as being blue-white, just as it is today. So it went from being a red giant to a blue-white star in less than 1,000 years. Well, what happens after it's become a blue-white star? There have been stars like FG Sagittae observed. FG Sagittae went from a blue star with a spectral temperature of 12,000 degrees to a yellow star with a spectral temperature of 5,000 degrees in 36 years. Now, this was reported in 1991, and since then it turned orange, red, and then brown and faded away, and now it's almost impossible to see it. It went through the whole process from a blue star to beyond a brown dwarf in less than 60 years. And they have found a whole class of stars just like it, fading away from a bright star to nothing in 60 years. How much confidence does that give us in the millions and billions of years of the stellar evolution story? And anyway, what are the stars? Good question. The first person to really tell us much about the stars was Giordano Bruno, and he said, "We know the sun is inhabited. We know the stars are inhabited. Therefore, the stars must be just like our sun." I don't think many people today would accept his reasoning, but they have accepted his conclusion. Well, what is the sun? Everybody tells us it's a great ball of gas with nuclear reactions going on inside it. Where did that idea come from? It came from a man called Arthur Eddington. Up to Arthur Eddington's time, it had been considered to be generating its heat and light by gravitational contraction, and a number of very prestigious scientists had shown that that is entirely feasible. With the observed measurements, it's quite possible for the sun to produce all the heat and light that we observe just from gravitational contraction. There was a problem with that, though. The problem is millions of years, because if the sun is contracting, then you look at a few million years ago where it would have been, and the Earth would have been inside it. So then the Earth couldn't be millions of years old, could it? So this was a problem, and Arthur Eddington, he said it produces heat and light by nuclear reactions. Now, did he have any observations or measurements to make that decision on? No. Just a pure brainwave. Well, the next stage in the story comes when a German astronomer called Hans Bethe is on a train in Germany, a train running along the Rhine towards Cologne. Now, I don't know if you've ever done that journey, but it's a bit boring once you get fed up of looking at the boats on the Rhine. And so he got out a piece of paper and he started working out how nuclear reactions could produce energy in the sun. And by the time he got to Cologne, he got it all worked out. This is how the sun produces energy by nuclear reactions. Any observations there? Any measurements? No, a piece of paper and a pencil, that's all you need. And everybody say, yes, that's how it must happen. And now if you look in the textbooks, it says that is how it does happen. How do you know? Well, Hans Peter worked it out on the train. That's how confident we are it's true. But there's a problem. A few years ago it was observed that the sun is actually pulsating. And when you do calculations on those pulsations, you cannot get the conditions inside the sun to be right for nuclear reactions. For those pulsations to happen, the sun cannot be hot enough for nuclear reactions. Well, that's a problem, isn't it? So they decided what they'll do is they'll take some measurements and see if there are nuclear reactions in the sun. And everybody agreed, if there are nuclear reactions in the sun, they will produce electron neutrinos. So, a detector was set up, Brookhaven Laboratory. This was put down at the bottom of the Homestakes gold mine. It is a very large detector for detecting electron neutrinos. Now they'd expected there would be some neutrinos around, floating around in space, coming from supernovas and other things like that. But they didn't know how many. So they set up this thing and it detected about 1/6 of the neutrinos they expected to come from the sun alone. So nobody knew where they came from, but only 1/6 of what they were supposed to find. So everybody said, oh, well, it obviously doesn't work. And then suddenly they got a burst of neutrinos. They said, oh, something's happening. And then they discovered a supernova, the first apparatus on Earth to detect a supernova. If there are electron neutrinos around, this can detect them. Couldn't detect any coming from the sun. So they built other detectors, built them in Japan, built them in Canada, built them all over the place. But nobody could detect any electron neutrinos coming from the sun. Now they could find some other kind of neutrinos, and they said, oh well, the neutrinos coming from the sun must have turned into these other kinds on the way from the sun. The problem is that the theory which predicts those neutrinos doesn't allow the neutrinos to change into anything. Are there any nuclear reactions in the sun? Nobody has been able to detect it. And if there are nuclear reactions, and the sun really does give out its heat and light from gravitation contraction, then those millions of years once again fall by the wayside. Now there is so much evidence like this in astronomy that John A. Eddy, who is one of the world's top experts, admitted this. I suspect that the sun is 4.5 billion years old. However, given some new and unexpected results to the contrary and some time for frantic readjustment, I suspect that we could live with Bishop Ussher's value for the age of the Earth and Sun. I don't think we have much in the way of observational evidence in astronomy to conflict with that. Theoretical evidence? Yes, all sorts of theories of millions of years. Observational evidence? No. Question: why should we believe the suspicions of the secular humanist astronomers rather than the clear word of the Bible? Ussher's value for the age of the Earth and the Sun was about 6,000 years. He got it simply by counting back the generations of the Bible. Why should we believe the suspicions of the astronomers rather than the clear statements of the Bible? But it wasn't the astronomers who first put forward the idea of all these millions of years. It was the geologists. Now, Dorsey Hager, he's dead now, but he was a very famous geologist, one of the most famous geologists in the oil field. And he was elected president of a geological society in America, and as part of his inauguration speech, he said this. Now, when you're being inaugurated in a society like that, you're not going to say something that all the other geologists disagree with. So he's saying something that's pretty widely accepted among the geologists. Early geologists fought to free people from the myths of biblical creation. Many millions still live in mental bondage, controlled by ignorant ranters who accept the Bible as the last word in science. You know, it sounds as if we've got somebody here with an agenda. It sounds like he's got an axe to grind. And what is his fight against? The Bible. You will always find the fight is against the Bible. No one is attempting to free people from the ignorant ranters who accept the Quran or the Tapitaka or the Vedas or the works of Confucius. The only thing they're fighting against is the Bible. Now, when he mentions early geologists, he is thinking in particular of one, Charles Lyell. Charles Lyell was actually a lawyer, but he turned to geology and he wrote a famous book called Principles of Geology. And when he'd written it, he wrote to Charles Darwin, who was one of his fellow Bible haters. And to Darwin he said, I have destroyed the book of Genesis without once mentioning the Bible. He had an agenda to destroy confidence in the Bible. A textbook on geology, which came out in 1986, had this to say: Lyell launched a crusade to lay to rest once and for all the idea that the earth and all things on it were the product of divine creation. Does it say he's searching for the truth about the age of the earth? Well, it doesn't say that. He's engaged in a crusade to discredit the Bible. And his chief weapon in that crusade is the geological column. And you'll see this has three parts. Over this side, there is a story of a progression of life forms on the earth. And I think we'll all recognize that effectively as being evolution. The second part is a series of rocks with fancy names. And those names are given according to the fossils they contain. Cambrian rocks are defined as those which contain these fossils. And Triassic are defined as the rocks that contain these fossils. Now, what Lyell did was to say, where in the world do we find the thickest stack of rocks, which we can call Cambrian? And you go to a place in the world where there's an enormous stack, and you say, that is the thickness of the Cambrian rocks. And anywhere on Earth where you don't find it that thick, they must have eroded away. Then you go and say, where is the thickest stack of rocks that are Ordovician? They've got these fossils. And that may be in a completely different place. And you say, right, that's the thickness of the Ordovician. And anywhere else in the world where it's thinner, they must have all eroded away. And so you go through everywhere looking for the thickest stack of rocks with that name, and you pile them all one on top of another and say, look how thick all this is. Now there's nowhere in the world where the rocks are that thick. Nowhere where they're anywhere near it. But there's another point. There's nowhere in the world where there is this sequence of fossils. There are a few places which are given this sequence of names of rocks, but it's not because the fossils are there, it's because, well, this must be WordVision because. But there aren't any WordVision fossils. So the few places where this order of rocks is there, it's because of other reasoning. And where you do find this order of rocks, they're not very thick. It's not the huge stack that this column has. This column is purely theoretical. And usually you don't find them in this order. You find some rocks from down here, and then you find some from there, and then some from here. Hey, how did these get all muddled up if this really is a sequence? This is purely theoretical, and it's a story based on the fossils. The story is that when you find these fossils, they were living then, and when you don't find them anymore, they've now become extinct. They've probably evolved into something else. They could no longer compete because the thing they evolved into was more efficient and they died out. So when something disappears from the fossil record, that is the end of it. Now, as far as this story goes, that received a severe blow when a coelacanth was landed in, I think, Port Elizabeth, or was it East London? It was either East London. Yeah. Now, the problem with the coelacanth is this disappears from the fossil record 63 million years ago. And the story had it that the coelacanth evolved into an amphibian. These strong lobe fins at the front became legs, and it came out on the land and it turned into an amphibian. So it disappeared. Well, after all, it would do if it turned into an amphibian, wouldn't it? Then when it was discovered in about 1936, I think, they discovered it hasn't changed into anything. It's still exactly as it was in the fossil record. The reason why they hadn't found any was that it never comes anywhere near the shore. It lives down at the bottom of the sea quite deep. It hadn't evolved into an amphibian. It had stayed exactly as it was. But now, if something that is supposed to be gone 63 million years ago is still alive, what does that do to the timescale? What does it do to the whole story? What does it do to the geological core? And since then, lots of things have been found, like the Tuatara. It disappears out of the geological record, supposedly 135 million years ago. It's still alive. Lingula disappears from the geological record 500 million years ago. Still alive. And dinosaurs, well, have we found any living dinosaurs? Well, possibly some water-dwelling ones, but even if we haven't found any living ones of these, there are temples like this one. It's close to Angkor Wat in Cambodia, and there are medallions containing the pictures of the animals that they worshipped. And there's an interesting one here, a creature with its head low, its tail low, and on its back it's got these distinctive shaped plates. Now, the only creature that anyone has ever come across that's like that is a stegosaur. That's supposed to have died out 65 million years ago. Now, in South America, there's been a large amount of pottery found, which has been dated at more than 1,000 years. And you can see on one of these pots, there's also a Stegosaurus. Well, there are some things that we're familiar with, like there's a goose, There's a fish, but look at this. That's a sauropod dinosaur. And look at that. And what about this? This is a triceratops. In pottery from another place in South America, also dated at least 1,000 years old, we've got a very interesting pot here, and it's got a triceratops. But look at this. There's a man riding on it. Well, some people are not very impressed with pottery, even if it is 1,000 years old. But here we've got a scientist who has caused big waves in paleontology. She is a very famous paleontologist. She's called Mary Schweitzer, and she's particularly famous because of her work with dinosaurs. And she has discovered dinosaurs, particularly T-Rexes, which are not fully fossilized, which contain blood vessels that are still elastic, still containing red blood cells. Now that doesn't seem to fit in too well with the idea that these things became extinct 65 million years ago. An even more interesting phenomenon, and that is finding woolly mammoths in ice. Now if you wonder how it got there, you need to read my book Another World, and you'll see this happening. But these woolly mammoths, if you look at the geological time scale, they died out about 1 million years ago. Now, how on earth did this thing stay preserved like this in ice for 1 million years? You know, the story of geology wouldn't allow for that. This is in ice which is moving towards the sea, and here in summer it started to melt, and you can see one of its feet is still perfect. This is not uncommon. A few years ago there was a very famous mammoth that came out of the ice called the Berezovkan mammoth, and steaks were cut from it and sent to the Royal Society in London, and they had a banquet where they ate mammoth steaks, and they were still fresh and good. Now, one can make up a reasonable story about ice like this lasting a few thousand years, but 1 million? No, it doesn't work. There is something so drastically wrong with this whole story that the geologists will not defend it anymore. The maths department tried for a year to get them to debate with me on the timescale. They wouldn't. But it's obvious why not. It's just not defensible. Well, there's one final thing I'd like to look at, and that is an area in South America, up in the Andes, at an elevation of about 4,000 meters. That's very high. It's so high, it's very cold. The only time of the year anybody goes up there, it's when shepherds take their sheep to graze on the sparse grass that just exists for a short time. Now, up in the mountains there is a lake called Lake Titicaca. And it's interesting because it's full of seawater. Way up there in the mountains, and yet it's full of seawater. Amazing. And not far away there is the ruins of an enormous city called Tiahuanaco. And the remains are very famous, and apart from the herd boys who go up in summer to see if there's any grazing in this cold, miserable place, the only other people who go are archaeologists. in this city, there are enormous temples, there are huge grain storage areas, and there are harbours and docks. It was once a seaport on a fertile area growing a great deal of grain, a big population. The archaeologists are convinced this is 4,000 years old. And if you look at the state of preservation of the stonework, one would wonder, is this really as old as 4,000 years? In 4,000 years, this city has risen from being a seaport to 4,000 meters above sea level. So if you ever hear the expression as old as the hills, you know that might mean 4,000 years. Well, when we look at what the earth has got to tell us, we might ask, how much time is there? How much time can we go back in the past? I don't believe we can go back anywhere near as far as most people believe. But what about the future? I believe we can't look as far as most people believe there either, because Jesus is coming back, and it's not going to be millions of years in the future. I doubt if it's going to be 1,000 years in the future. I doubt if it's even 100 years away. I think we need to not only be conscious of the fact that history is not what we think, but the future is probably not what we think. And we need to be ready for when he does come, because it might be tomorrow.
Let me break the ice. So if you with a calculated guess, if you have it, how old do you think the Earth is then, more or less? If you have to give a number.
Not much more than 6,000 years. I personally don't believe that the information given in the Bible is specific enough to be able to calculate it to the day like Usher believed. I believe there are some conventions that are used in the Bible which are quite clear, but that makes the exact determination not really possible. I think if God had wanted us to know, He would have made it very clear. I don't think it's important for us to know, but I think all the evidence is that it's certainly not as old as 10,000 years, and I would say it's closer to 6.
Do you think a place like, say for example, the Grand Canyon could be formed in 6,000 years, or was that created like that? the depth of the Grand Canyon, could that be formed in 6,000 years? Or have we told that?
Well, I think we'll look next week at the formation of a canyon which was known to be formed. It took one day. The assumptions in the Grand Canyon we might well look at next.
Okay, thanks.
Yeah, I might ask something. When I was growing up, I don't know, I think it was maybe in school where they teach where Africa and all the continents were one and they separated somewhere. Is that still relevant, or is that also part of the evolution?
No, that idea was first put forward by a man called Antonio Snyder. He wrote a book called Mysteries of Creation Revealed. And I remember a number of years ago when I was at the Library of Parliament in Cape Town, his book was open to the very page which dealt with continental drift. Now, Snyder put forward the idea of continental drift because he said, the Bible says that God collected all the water into one place and called it the sea. So he said, well, if all the water was in one place, then all the land must have been in one place too. And he found later on, in the days of Peleg, the earth was divided. So he said, well, let's have a look at the globe and see if it looks as if the earth was one and got divided. And so he came up with the idea of the one big continent having broken up and moved apart. And his map showing that continental drift was the page to which his book was open in the library. I don't know if it still is. But the geological fraternity said, in the days of Peleg. In days? No. Things in geology happen over millions of years. This is a fairy story. And it remained a fairy story until the Second World War. Now, in the Second World War, there was an enormous development in submarine technology. And it enabled a very thorough exploration of the seabed. And to everybody's surprise, the seabed turned out to be nothing like any of the theories of geology would allow it to be. It showed that all the theories they had were wrong, and the one which was least wrong was continental drift. So although it was obviously still wrong, there was lots of physical evidence that shows it cannot be true, it was the least wrong theory they had, so they said, oh well, yes, continental drift. But not like Snyder said in the days of Peleg, quickly. Over millions of years. So then they decided to prove this. And they decided to do it by measuring across the Atlantic from the North American plate over to Europe. And they said, well, those plates are separate, they should be moving. But the method you use for measuring distances like that, it needs atmospheric corrections. You do it by sending a beam, a radio beam or some electromagnetic radiation beam, and that is affected by the atmosphere. So you have to make corrections. And to get an idea of how good your corrections are, you always do a control. So they set up another point the same distance away on the North American plate, and they measured that distance and they measured that distance. Now this one was supposed to move and this was supposed to not. So the measurement is the measurement you get here minus what you get there. So they got 2 centimeters movement in a year. And they got 2 centimeters movement in a year. So what happens when you take the correction off 0? But they didn't report the 1 the control, the one on the North American plate. They said, 2 centimeters here, we've measured it. Well, of course, you can't carry on measuring something that doesn't exist for very long before you have to admit that something's wrong. So now they say the continents move but very slowly and it's difficult to measure the actual rate, meaning they can't measure the rate at all because presumably there isn't movement across that plate. Now, the physics of continental drift does not work as they have it. It requires an enormous force to break up the plates. It requires a huge force to move them. Now, the story they tell is about convection currents in the liquid part of the Earth somehow moving the plates, but they're thousands of kilometers below the plates, and what's in between is supposed to be solid. So how on earth this moving current in the liquid outer core could possibly affect the continents is just not feasible. They haven't got a mechanism, and they haven't got movement either. They've just got a story. Now, tomorrow we will look at a feasible mechanism for continental drift, but it doesn't happen slowly. The only feasible mechanism I've come across is exactly what Antonio Snyder said. He said it happened in the days of Peleg, immediately after the flood, and as a result of the catastrophic upheaval in the flood.
Just a quick question on that. I also heard that in order to fit all the continents together, they have to shrink it something like 80%. Or is that true?
Well, they have to miss out quite a bit the Caribbean. They have to change the size of Africa. They have to do a lot of fiddling. But if instead you do as Snyder did and fit together the continental shelves, then the fit is quite good. But it doesn't work the way they tell you in the textbooks, because they have to shrink and expand and miss things out without telling you.
So does it still mean Africa is a cradle of mankind, or is that just a story?
Cradle of mankind. Oh, that's an interesting story. Perhaps you've heard of African Eve. You haven't? Oh, this was a really big thing in science. What happened was they looked at mitochondrial DNA and they got samples from people all over the world. And they put this data into their program, and their program said all the people in the world are the descendants of one woman. Amazing. So everybody said, oh wow, all descended from one woman. And then the results said that this first woman was an African. But then people put the data in again. They discovered that whichever data you put in first, that turns out to be the mother. They all agree that it is, all the data shows that everyone descended from one woman. But if you put in the Chinese first, then they all descended from a Chinese woman. And what had happened is they first put in the data from Africa, and so it said Africa was the first. But you see, once you've got something going, and it's been through the newspapers and it's made a big hit, then nobody's going to change the story just because they find out it was wrong. But they did agree. Everybody must have descended from one woman. Amazing. Then they did some more research on male genetic material, and they said, amazing, the data shows that everybody descended from one man. But that one man never met that one woman. No. They're quite happy to have everyone descended from one woman and from one man, but not that those two were the first people. That is just not acceptable.
Okay, maybe I must ask one of my crazy questions again. You spoke about the stars in the universe and so, and we have more or less an idea of how big it is, but does it end somewhere? Maybe not, you know, does it just go on and on and on and on? Or is there some place it just ends? You know what I mean?
Yes, you say we've got a good idea of the universe. Where does your idea come from?
Perception, media, stars, your pictures I've seen.
Well, if you're going to rely on the media, then you're going to rely on evolution, you're going to rely on millions of years, aren't you? What makes you think that astronomy is any better?
And it's just my starting point, my frame of reference, but beyond that, do you think it can just go on forever, or does it end somewhere?
Have you been to all the meetings?
No, I've missed the second one.
Ah, we looked at that in the second one, but we'll get back to it on the last one. It's a very important question, and it's to me very, very sad to see how many Christian astronomers look at all the things the secular astronomists are telling us. They say, oh my, isn't God wonderful to have done it like that? But did God do it the way the secular humanists say? He certainly didn't do evolution the way the secular humanists say. He certainly didn't make the earth the way the secular geologists say. Why should we believe that he made the universe the way the secular humanists say he made the universe?
I have carbon-14 dating. I think it's still being used rather extensively. And as I understand it, it's got a limited lifespan. So it cannot even date beyond 1 million years. So I wouldn't understand why people use it like that. But could you perhaps explain it a bit in more detail, the whole carbon-14?
Well, if carbon-14 worked the way the theory says it should work, then it ought to be able to date things back to something like 50,000 years. But it doesn't work the way it's supposed to. Now remember, I said that the rate of production of carbon-14 has been measured, and the amount in the atmosphere has been measured. And there is enough to account for the process going on about 10,000 years. The carbon-14 method assumes the Earth has had a constant level of carbon-14 for at least 50,000 years, because the earliest date you want to try and do, it must have had that constant level of carbon dioxide. Of carbon-14. Now, if you start off with the Earth having no carbon-14, so we're right down here at the bottom at 0, the first year that the sun is shining and we're getting carbon-14 formed, I've forgotten how much, I think it's 8 kilograms that will form. So you'll have 8 kilograms in the atmosphere. It's very, very little. And with only 8 kilograms, you'll have almost none of it decaying. So the next year, you'll have another new 8 kilograms, and almost the whole of the last. Now, as time goes on, you build up more and more, and as you've got more, more decays away. You'll get equilibrium when 8 kilograms are being formed, and there is so much that 8 kilograms decays away. Then it can be constant. And to reach that point should take 30,000 years. Now, in his book, Radiocarbon Dating, on page 7, he points out that the amount in the atmosphere is still 20% below the equilibrium level. Now he was being optimistic. More accurate measurements show it's more than that. No, in his book he says it's 18%, and it's more than that, it's about 22%. Now, 22% below equilibrium you reach after about 10,000 years. Now, if you start doing dating, you assume that in the past you've had this high level of carbon-14. So that all the creatures that breathed the air were breathing in all this radioactive carbon-14, and when you look at their body now, some of it's decayed away. But that assumes you've had this level way back for 50,000 years. But in fact, you've had a rising curve, so something that was 10,000 years old would have had no carbon-14 in it when it started, because the level was 0. If you look at something which was, say, 5,000 years ago, it would have such a small amount of carbon-14 that if you assume it started off there and it only started off here, you would get a huge age when it's not a huge age at all. Now, the reason why carbon-14 can be of some use is that instead of just doing the calculation as they do with all the other radioactive methods, radio decay methods, what they did was to take objects of known age and say, well, we know this age is that, when we get that percentage, it must be that age. Then you're not relying on any theory at all, it's just that when we measure things we know to be that age, we get that percent. So it ought to work back to about 4,000 years. But it doesn't. Because it assumes that the carbon-14 inside a person, in fact all the carbon, comes from the atmosphere. And it assumes that all the plants just take in carbon dioxide for producing food, and there will be carbon-14 with the normal carbon. That's not the case. Unless a plant is growing very quickly, it closes its pores so that it preferentially leaves the carbon-14 out. After all, it's bad for it, it's radioactive. If it's growing very quickly, it has to keep its pores open so more carbon-14 gets in. So the amount that gets in depends largely on the speed at which it grows. Some plants are much more effective at keeping carbon-14 out than others. So some plants take in very little, some plants take in plenty. So if you have a plant which had very little to start with and you date it, you will estimate a far older date than is true. And if you have something which has been feeding on the plants which exclude it, then also you'll get dates which are not feasible. And you can easily see that's the case, because when you date creatures of known age, you get carbon-14 dates which are totally ridiculous. For example, there have been cases where a piece of shell has been broken off a living snail. Carbon-14 dating then says that snail died 22,000 years ago. It doesn't work. It's the best of the dating methods, but it's still hopeless.
Can I ask again? My follow-up question to that is, since you say it's one of the most reliable ones, or the best ones out there, are there any data methods that are quite accurate and that actually give a young age? Are there any solutions to this whole thing, or will it always be a mystery?
Well, there are one or two dating methods which look as if they have got promise, but it's difficult to know because you can only calibrate them with things that you know the age of. Now, one which really does seem to have promise is racemization. When you have a living organism, all its DNA uses right-handed amino acids. Right-handed nucleotides. And its proteins, use amino acids which are all left-handed. Now that doesn't normally occur in nature. If you get amino acids in nature, they're a mixture. But life can only use left-handed ones. But if you leave it outside the body, they randomly switch. And over time, they go back to a racemic mixture. When that happens in your body, when an amino acid in a protein switches, then that protein is no longer any use, it has to be destroyed, it's recycled, and the useful amino acids are used again. And it seems that that happens at a pretty regular rate. So if one looks at a dead creature, and you look at the proteins, or you look at the amino acids, or you look at the DNA, you can gain an idea of how long it is since it died by the amount of racemization that has taken place. Now that's interesting because they can only reproduce DNA when it has strings of a reasonable length. So as soon as you've had enough racemization to chop your DNA up into little strands, you can't recognize it anymore. And they reckon that the absolute maximum that DNA can still be recognizable is 50,000 years. Now, that's not a lot of time when you consider what they say they are doing. For example, you've probably heard of the story that they did an investigation on Neanderthal DNA. And the Neanderthal DNA claimed, they claimed that it showed that Neanderthals diverged from modern humans 650,000 years ago. Now that's interesting because if the Neanderthal specimen that they had got was as old as 50,000 years, they couldn't have found anything to do a test on. So the absolute maximum age of the thing they were working on is 50,000 years. And they say this thing diverged from the line of human beings 650,000 years. You see what they're saying? They are telling us utter nonsense. They are telling us lies, and I think we're so stupid we can't put two and two together. If they can analyze Neanderthal DNA, they are at an absolute maximum, 50,000 years old. They say they have got dinosaur DNA from mosquitoes trapped in amber. They say these mosquitoes landed on dinosaurs, sucked some blood, and now they've taken out the blood from these and they can do a DNA test. And now, just a minute. The absolute maximum that could be is 50,000 years. How come this can be from something that died 65 million years ago? It's very interesting, racemization. It really shows all their stories to be utter and complete nonsense.
Does no one ask him about this, or do they have a method of reasoning if the question comes up that they use? Why they can add it up to that?
I don't know. It's becoming very difficult to to ask these people questions. I think it was last year or the year before, there was a big do at the university because of the Darwin Festival. And there were lectures by famous evolutionists. And I inquired, I said, is there going to be question and answer at the end of it? They said, no questions and answers. So I didn't bother to go. See, if they refuse to face questions, they can tell you whatever stories they want, and shut up shop, and they cannot be exposed as the frauds that they are. They know it, that's why they won't have questions and answers. They know it, that's why they won't debate. There was a time when they would debate. I used to debate quite often. People were once quite happy. I once did a debate in Holland where there were 3 members of the university staff there. There was one from biology, one from paleontology, and one from geology. And they soon discovered they hadn't got one argument between them. But now they know it, so now they refuse to debate.
As to what the sun actually, how's that pulsating? How does that generate the heat and all that? I don't understand that.
No, it doesn't generate the heat. It has been believed for quite a long time, before the nuclear story came, that it generates its heat by gravitational contraction. When things contract in on themselves, they get hotter. When they expand, they get cooler. Helmholtz, I think, was the first one to propose it, and Kelvin, who was perhaps the greatest scientist of his time, checked his calculations and agreed. Measurements of the sun's diameter certainly seem to suggest a contraction which would fit in with their calculations. It could produce all the heat and light that we see from the sun. But as it's getting smaller, that could not go on for a vast amount of time. And the only reason why that explanation was ever overturned was because people realized that could not allow evolution. Because the timescale is cut down as soon as you have that mechanism. So the idea of nuclear reactions, it has never been established. It has, as far as I'm concerned, been refuted by the lack of electron neutrinos, but they don't want to let it go because you've got to let go of the millions of years if you let go of nuclear reactions.
The most saddest part is for me that they still leave it in the syllabus to teach, even though there's so many people that know that's not right. But as I understand, they're powerless to change it or to go up against the evolution.
Yeah. Oh, no, look, as I pointed out last time, when you look at Haeckel's drawings of the embryos, it is just patent fraud. And yet, the people in the administration say, no, this illustrates evolution, evolution's true, how can it be a fraud? They're not interested in the truth.
It's fairly interesting. I've watched a lot of debates as well, and it's always the most interesting people, scientists, are creationists. And I'm not trying to just say that biased, but it's because they work with science. Philip mentioned something a few weeks ago that I don't know who said it, but yeah, it was last week. That if science makes it very difficult, and that's why the evolutionists don't explain to us how the theory has evolved, because the normal people like us wouldn't understand it. Whereas real science is very close to logic. The thing that makes easiest sense, and then you just prove it. It shouldn't be that difficult. And I think that's why when you look at the debates and so forth, every time, that's why they probably don't debate creationists so much anymore. They look really like utter fools. They will stand there and somebody will put in for science, and you can see this guy doesn't even know what the creationist is talking about. Because it's like they're learning a set of paradigms. They're not learning science, how to do science for themselves, how to think for themselves. And I think that's the great thing that Philip mentioned 2 weeks ago, that any person can be involved with this. Science is not just for the guy with the PhD. It's for anyone with a brain and with an interest to search behind things for answers and so forth. I think it's very good. I have a quick question.
Can I just comment on that? The evolutionist that I mentioned, Joel Duff, when I questioned him, he said, we cannot tell the truth about evolution. People would not understand and would be confused. Now, Einstein said, any scientist who cannot explain what he's doing to a 12-year-old is a charlatan.
If I, for example, was a very clever and intelligent matriculant that wants to go study science, do you think I can go to the University of Bloemfontein? Do you think there's a place for them?
If you've got your eyes wide open, yes. My daughter studied at 3 universities and she got distinctions every time. And she followed the same pattern that she had done all the way through her education. You come to a question and you give them everything that the examiner wants to hear. And what she would do is she would put the whole story down and then say, but, and then she would show all the things that show it's false. Now, she's got everything they wanted to hear, so they've got to give her the marks. And then she's got the bit at the end destroying it all. And well, they can't take any marks off, can they? So she got distinctions for everything. Now, I think the second university she was at was Potch. And eventually her lecturers came to her and said, where do you get all this from? They said, oh, well, I get it from my father. He gives lectures on this thing. So they said, well, maybe you should invite him to come and lecture here. It was the most amazing lecture I've ever given. I got into the lecture hall, and there were the botanists and the zoologists and all the lecturers, and there was an old professor who was the dean. And just as I was about to start my lecture, he stood up and he said, some people don't believe in evolution. They don't know very much. Now, we're going to listen to a lecture, and after it, the members of staff will answer. And if there's any time left over, the students can ask questions if they have any. And then he sat down, and I thought, my, what a nice introduction. Yes, very kind of him. So I launched into my lecture on evolution, and I looked around, and after 10 minutes I could see every single student in that place no longer believed in evolution. And I looked at the dean of the faculty. He was sitting on his chair, gripping the arms of his chair with his knuckles showing white. I really enjoyed it, and I carried through to the end of the lecture, and then waited for the staff to put in their refutations. This fellow just sat there, absolutely ashen grey, gripping his seat. He never said a word. And the members of staff looked from one to another. You know, they knew they were supposed to now demolish me. And then one of them made some irrelevant comment. You know, it wasn't attempting to refute anything at all I'd say. He just made some irrelevant comment. And everybody looked around at these embarrassed lecturers, and then the students started asking, and they started asking good questions. I was never asked back again.